happy to be here today to talk about one of my favorite research topics, the irregular shelterwood system. Okay, so there's some technology. Okay, fine. From the bottom. Managing for species mixture with contrasted ecological requirements can be highly desirable from an economic and ecological point of view, especially to promote the resistance and resilience for climate change. And however, they're quite challenging to achieve in practice. And based on the premise that a variety of ecological niches can promote a diversity of species, the application of irregular shelterwood systems can offer a good potential to achieve multi-species management in temperate forests. During this talk, we'll explain what is the irregular shelterwood method. Many of you probably have already heard about it, but it's worth to look at that. And then we'll discuss the three overarching variants. Then I will also talk about the research program we have developed in my research branch and the Ministry of Natural Resources and the Forest. And finally, I will present an example from an experiment in a temperate mixed wood that I've set up with my team. So, the irregular shelterwood method is, as it says, a regeneration method. With the goal is to establish regeneration at most of entries. It's different than the regular shelterwood method because the regeneration period lays over more than a fifth of the rotation length. So by definition, you have more than 2 age classes. So and an uneven age stem. So typically it has 2 to 4 classes when you have irregular stems. And the system also differs from the selection cutting because you're not aiming at having a balanced stem over time and so the age classes are not evenly distributed to permit the harvest of large trees at regular intervals indefinitely. With the irregular shelterwood method, we have different silvicultural goals, which are quite similar to the goals of the selection cutting method. First, we want, of course, to create the favorable conditions to establish a new cohort of seedlings from different species. We also want to release the advanced regeneration that will benefit of the increased light and other resources after the partial cut. Of course, harvesting the mature trees and to improve the stem quality. So in the review we have published in 2009, we realized there were many variants existing worldwide, but most of them could be classified in 3 overarching variants: the expanding gap irregular shelterwood, the continuous cover irregular shelterwood, and the extended irregular shelterwood. I'll give a few examples in the next slides. So with the expanding gap irregular shelterwood, we enter into a stem to do a first establishment cut that creates groups that will be gradually enlarged until the whole stem is harvested. And sometimes we can also not do the final cut if you want to let some legacy trees there. A good example of this variant is the Acadian Fermenschlag, developed in Maine spruce-fir forest by Bob Seymour and his colleagues. And this variant applies well to even age stems or even age stems. And since you create gaps, you can also promote the regeneration of less shade-tolerant species such as yellow birch, white pine, red oak. That's what they were succeeding to do in Maine. With the continuous cover irregular shelterwood, we conduct the different establishment cuts on long cutting intervals, similarly to a selection cutting system, like a single tree selection cutting. But there's no, we don't aim to do any tending, and you can harvest single trees or small groups of trees. It's rather the basal area, residual area that you control, for instance. The goal is to establish a cohort at each entry so that you have a continuous cover and irregular shelterwood, an irregular stem structure. Sorry. And the main difference with the two other variants is there is no final removal. So if you are in mixed stands, such as on this photo, it's a yellow birch coniferous stand in a temperate forest. It's a good way to harvest the short-lived species like balsam fir, paper birch, and other less desired species like red maple, while promoting those that are long-lived and late successional, such as yellow birch and red spruce. With the extended irregular shelterwood, well, it's quite similar to the regular shelterwood. You can envision it the same way. However, it will take more time before you do the final removal. And since it will be, for example, 25 years, 30 years, you will have at least two age classes. That's why it falls into the category of irregular shelterwood. And depending on your goals, the final removal can be optional if you want, for example, to transform an even age stand into an irregular stand structure. In this example, we used it in our balsam fir yellow birch stands that had an irregular stand structure. It's also we also use it in poorer quality yellow birch conifer stands. So a few words about our research program. So in 2005, a group of researchers from the Forest Research Branch where I work, with Steve Bédard and Stéphane Tremblay and others, we launched that research program. And since then, we have established 1 experiment in the northern hardwoods, 2 in the temperate mixedwood, and 3 in the boreal forest. And we all have the same similar experimental design with 4 applications of 5 treatments. We have 2 variants of irregular shelterwood compared to control and to 2 current practices. And we also have the same sampling methods, so that's quite interesting. So during this talk, I will be talking about the CPI-M1 experiment, and Steve will present the results from the CPI-F1 in the sugar maple yellow birch right after me. So the CPI-M1 experiment is conducted in the balsam fir yellow birch, which is similar to the Acadian spruce-fir forest in the US. The main species are balsam fir, red spruce, red maple, and yellow birch. And the natural dynamics of this forest type is characterized by light and moderate disturbances caused by the spruce budworm cyclic epidemics, and there is also the background mortality, of course, of trees that die over time, which causes the gap dynamic. And since this whole research program was established in the context of ecosystem management, our goal with this project is to emulate these light and moderate disturbances with irregular shelterwood. So here's the experimental design. We have the uncut control with an average basal area of 30 square meters per hectare. We have the continuous cover irregular shelterwood with the scenario to come back roughly every 30 years. And the residual basal area is 19 square meters per hectare. The harvest intensity was slightly higher with the extended irregular shelterwood, where the residual basal area was 17 square meters per hectare after the cut. This was set in 2009, and we plan to do the final removal after 30 years. As current practice, we have the uniform shelterwood, where half of basal area was removed, and we were planning to do the final removal after 10 years, but we have done it after 12 years recently. And finally, which is the one that is really the most current practice in this forest type, is clear cut. But actually, it's a clear cut with the protection of regeneration and soils, also called clag in Canada, at least. And in the clear cut, so all metrotypical trees were removed, conifers larger than 9 centimeters, and hardwood larger than 23 centimeters. So given the context, ecosystem management was the first time we were trying to conduct irregular shelterwood. To do that in these stands, we did the tree marking. So here are the guidelines. They are based on tree vigor and species priorities. So we remove the weak trees first, and the short-lived species also first. The aspen larger than 20 centimeters, because it grows quite fast on these sites, and after that there is more decay. Aspen and paper birch. We also had retention modalities. We aim to have at least 10 snags per hectare and 6 wildlife trees per hectare, including 1 veteran tree of long-lived species such as red spruce and yellow birch. And these are our target species, by the way. We want to promote the red spruce regeneration, yellow birch, and balsam fir. Operations were conducted in fall 2009, and there was the soil was not the ground was not frozen because we aim to benefit of the passive scarification by the machinery, and the operations were conventional with chainsaw and cable timberjack skidder. Now let's see what are the results. So it's the result from the first 5 years after the treatments. So the first finding is that the shelterwood treatments diversified the understory conditions. Here we have a graph showing the light conditions right after the treatments. You can see here on the control graph that the light conditions were really poor, were quite low in the control, barely reaching 30% light in some areas, and while the average was 16% light, which is quite low to regenerate the species we want to regenerate, even the shade-tolerant ones. So using the shelterwood treatments, we could double the mean available light for the regeneration. But we could also diversify the light conditions. So if you look at the gray bars, you see there's a diversification of the transmitted light conditions, which could, in theory, accommodate a diversity of species, because you could accommodate more light-demanding species. Similarly, for seed beds, we could diversify the seed bed conditions. If you look at the bars in the bottom, you see the white one, it's the undisturbed seed bed. Undisturbed humus, which is not the best seed bed for the species we want to regenerate. So with all these cutting treatments, we were able to decrease the percent cover of the undisturbed seed bed, and while increasing the coverage of favorable seed beds such as mineral, organic mineral, and disturbed humus compared to the control. Regeneration-wise, we were pleased that the shelterwood treatments to see that the shelterwood treatments could establish a new cohort of mixed species regeneration. We will first look at the results for the yellow birch, the small regeneration, smaller than 30 centimeters, and there was a significant interaction of treatments with time, but we will focus on the 5th year, and you can see, well, without surprise, that all the cutting treatments significantly increase the yellow birch density compared to the uncut control. The yellow birch is a species that responds well to ground and cover disturbance, so it's no surprise, but it's always fun to see that. Okay, the story is a little different for the conifers. If we look at now the red spruce regeneration, focusing on the 5th year, we see that well, only the continuous cover irregular shelterwood significantly increased the red spruce density compared to the clear cut, and was not significantly different from the other shelterwood and uncut treatments. And for balsam fir, it was a single effect of the cutting treatments. Oops. Okay. So here we have the balsam fir regeneration, which was higher in the control in continuous cover irregular shelterwood compared to the clear cut. So here we have that clear cut obviously is not really a good treatment for regenerating the conifers in this mixed wood forest type. Why? Well, when we go in the field, we know that. We see all this heavy competition, but the data and the results also show that the reason is mostly the shrub cover. Again, if we focus on the 5th year, we can see that the clear cut has more than double of person cover in shrub species compared to the uncut control and the continuous cover irregular shelterwood. So this may explain the results we have found. And I don't have the results here, I don't have the graphs to show you, but the pin cherry coverage, well, the two main species in that competition layer were the pin cherry and the red maple. The pin cherry was significantly limited by the shelterwood treatments, but not the red maple. So it's always a fight with the red maple. And last finding, the irregular shelterwood better achieve the structural objectives. If we look at the diameter structure, we can see that the continuous cover and extended irregular shelterwood have quite similar diameter structures compared to the control, while it differs much more with the regular shelterwood and the clear cut treatments. We also look at the snag abundance. So if we look at the gray bars, the snag abundance was significantly decreased in the clear cut compared to the other treatments. And we know that the continuous cover extended and regular shelterwood were not significantly decreased compared to the control. But we must keep in mind that okay, so that's the orange, it's at 19, okay. But I'm almost done, Greg. It'll be fine. Okay. So maybe last result, the tree-related microhabitats. My colleague Maxence Martin looked at the tree-related microhabitats, just like the cavities, the bark losses, fungi, all those features that can that are important for species diversity. I know it's getting fancy there, but you look at that and you can see here that again in the clear cut the number of tree bearers per hectare were much lower in the clear cut and decreased compared to the control, and there was no significant effect for the shelterwood treatments. And when he looked at the diversity of these tree-related microhabitats, then we had similar trends. So decrease in the clear cut while quite maintained in the shelterwood treatments. And yeah, since we had retention modalities, we conducted these shelterwood treatments with retention modalities and the tree marking. That shows that probably it was quite helpful to maintain these attributes. But we must also consider the timing of the different scenarios. Of course, in the shelterwood treatment, after the final cut, there are not much anymore of these snags and tree-related microhabitats. So it would be interesting to remeasure all that after the cut and see what happened. Okay, so if we wrap up, after 5 years, after the application of all these treatments, you could see that the shelterwood treatments could diversify the industry conditions. We could establish a new cohort of target species, mixed species, especially in the shelterwoods, and the clear cuts had little conifer regeneration because of the heavy competition. Also, partial cover contributed to limit the competition. And overall, the continuous cover irregular shelterwood better achieve the compositional and structural objectives. And these, of course, are quite short-term results, but it will be really interesting to see over time if these trends maintain. So we think that using the irregular shelterwood as a way to emulate the natural dynamics has proven to work quite well up to now. It will be interesting to see what happens in the future. So thanks to all the persons who contributed to do this work, and I'll be happy to take any question.
Mine will be quick. Do you have any current research or plans for research to include expanding gaps in comparisons with some of these other irregular shelterwood methods?
No, we did not include this variant because we work in hilly areas, and that's one thing I wanted to say is that it's harder to apply when it's not flat, when the slope is not gentle, because it's when you apply a geometric pattern, you have too many constraints if it's hilly. So, maybe in the future in another experiment.
Thanks for the presentation. That's great. I had a question. In your broader regular shelterwood research program, do you have any work sort of planned or in the not too distant future on second entry studies?
Second entry, you mean in 15 or 20 years?
Yeah.
Yeah. Oh, yeah. Sure, we will. Well, hopefully, I don't know if I will be the person who will do it, but of course, these are long-term research projects. So they will be. We have planned to follow these 25, 30 years, and maybe if we can, we will ask for more time. But every 5 years, we ask for funding, and if we make it, we can continue. But usually it goes well because I think it's a really nice project from the ministry and they want it to continue, so I'm not worried.
In the extended shelterwood, some publications in the United States suggest much lower basal area after treatment. What's the rationale for choosing a higher residual basal area, and do you think it could have some potential benefits to make it lower? Or I think that some of these publications have used irregular shelterwoods as a way to mitigate clear cuts.
Yeah.
Not necessarily in a very silvicultural way. Is that your opinion, or?
my opinion is that in these forest types, really they are rich sites, and there's so much competition that if you open more, you have even more trouble. And if you have different goals for regeneration and structural attributes and eventually carbon, whatever, it gets more tricky. Yeah, I would not recommend that on these sites. But I know that clag is super popular and used. But if you want to do a partial cut, to me, when you harvest more than 50% of the cover, it's not really a partial cut, but it's my opinion.